the Haomin. I'm the person who will introduce how our project will work. Assuming that I'm now in our primary persona as a 20 to 30 years old student, and I want to order some food in our local restaurants. And we have already had account in our system, so I will tell you how to log in here. So assume we have this account. Now we enter our password. Then we click login to log in our home page. And if you see that web page, it means you have logged in successfully. And for you can see at the middle of the language button and log out button, it will show your username and what is your account number. And if you want to log out, you can just simply click the logout button. It will let you log out. And right now we have 3 language preference: English, French, and Chinese. You can select whatever you want if you want to switch your language. And at this button, at this box, we have preference collection box. It will have 5 information that we want to collect. For the first one, it is directory preference. We right now have 3 options you can select. For the default value is no, and if you are vectoring or the gluten-free, you can select. And for this button, I just select no. And for the second box, it is favorite cuisines. Say I would like to have bulgogi. It is Korean food, and when I finish it, I can just simply click add button. It will add your preference to your. It will add this information to your preference. And for the disliked ingredients, because I don't have any food ingredients that I dislike, so I just leave it empty. And for the spiciness level, I will choose the mild spicy level. And for the last allergies, I will enter peanut. And then I just click the add button. It will add this information to my preference. So after we have done all of this, we just simply click the save preference, and it will. If you receive this information, it means you have updated your preference successfully, and then you can just go to the next step. Say if I want beef as my food, and we will click generate button, and our large language model will generate some menu and generate some food for you based on your updated preference. Say this page, we have bulgogi, and it will have some information about this food. If you like it, you can just click the favorite button. It is hard. You can click that. It will add this food to your wish list, and then you will go to the next meal. And see if you don't like it, you just click the next button and to see the next food. And for this food, if you like it, you can just click the heart, like the favorite button. It will add to your wish list. So now we can view our selections in the wish list. For this page, you can view that which food you have selected for your meal or for your lunch. And if you misselected some food, you can click the favorite button. It will remove that food from your wish list. And I think that's all my our user journey.
My name's Edwin, and I'm now going to introduce about the high-level technical details of our project. We are using MongoDB, a NoSQL database for as our database option, so that you will scale better, and you will also allow us to store more information as needed. So we have 3 tables here: one for the menu PDFs, one for the restaurant information, and one for the users. So here we have uploaded some menu PDFs, and we store them in AWS. We store them using S3 bucket. So, and we also store the links here. So for the whole project, we are building a RAG system, retrieval augmented generation system. So we generate a response with a logic context. In our case, it will be the restaurant menu, and we combine it with the user preferences and the user query, which is, for example, the beef we talked about, to generate the response and the recommendation and order them to show them in the front-end client side. For our vector database option, we are using PyCon. We are using the PyCon vector database as our to build a RAG system. And for the OpenAI API, we are using GPT-4o as the model that generates all those responses. So we are using React as our front end and using Python Flask as our backend server. So we are building it with the front end and back end separated, and using the MongoDB as database, vector database using PyCon, and here is all the details about our tech stacks used.
Hi everyone, in this section of demo, I'll walk you through some of the challenges we faced during the development of our AI-powered wader system and how we overcame them. One significant challenge was ensuring stable integration between our Flask backend and MongoDB. During load testing, the database connections time out intermittently, especially when handling concurrent user requests. To resolve this, we implement a retry mechanism with exponential backoff and fine-tune the MongoDB server configurations. This approach not only stabilized the connection but also improved the overall performance of the application under heavy loads. Another critical issue was with our OpenAI and vector database integration. When processing complex or uncommon queries, the GPT-4 API occasionally returns null responses, causing our recommendation engine to halt. To address this, we added a fallback mechanism to handle null responses and conducted further testing to refine our API call parameters. This ensures smoother query handling and more consistent results from the recommendation engine. The recommendation system itself presented a unique set of challenges. During testing, we found that when users provided highly specific preferences, such as low carb, dairy-free, and spicy, the system sometimes returned irrelevant results or error messages. To fix this, we enhanced the filtering logics in the recommendation engine and added detailed parsing rules to better interpret complex inputs. These improvements increased the system's accuracy and reliability in catering to user needs. Another challenge involved is the manual processing pipeline. When uploading PDFs of restaurant menus, some files with complex formatting failed to generate proper embeddings. To resolve this, we optimized the memory allocation for our embedding generation function and introduced a chunk-based processing system for larger files. This adjustment allowed the system to handle a wider range of menu formats without errors. On the user interface side, we faced usability issues with interactive menu. Early feedback revealed that users found it difficult to navigate the menu and access dish details. To address this, we simplified the layout, added tooltips for better guidelines, and implement visual feedbacks like button animations. Additionally, we included a consistent navigation flow to ensure users could easily return to previous pages. On the one final challenge was the system's response time when users switched between recommendation pages or canceled order quickly. The system occasionally displayed outdated information due to caching delays. We resolved this by introducing real-time state updates and optimizing the caching settings to ensure synchronization. Loading indicators were also added to enhance the user experience during transitions. Through these challenges, we've learned the value of iterating testing, collaborative problem solving, and paying close attention to user feedbacks. Each hurdle has brought us closer to building a more reliable and user-friendly product. Thank you for listening, and we hope you enjoy exploring the rest of our demo.